Before example 2, your textbook has the binomial theorem written out in the box, and it says using combinations, and it says using algebraic expansion. You do not need to know all the algebraic expansion is using the combinations to figure things out. Now, what we notice is these and choose things, those were just your numbers from Pascal's triangle. So Pascal's triangle matches up with your combinations at the front. We also notice the same pattern, whatever term is first, which I'll underline in green, you start with, I'll highlight my exponent here in green. You would start with n of them here, because that's my exponent, then one less, then another one less, and keep going down by one all the way. With your second term, which I'll underline in purple, we notice that we start with none of them, then 1, then 2, then 3, and we keep going up until we get to all n of them. Some other patterns that we noticed is that there are n plus 1 terms in the expansion. So if your exponent is n, you'd have one more than that, would be how many terms in total you have in your expansion. Now, on your formula sheet, what your formula sheet has, instead of having this all written out like they have in your textbook here, what your formula sheet has is the following. So it has tk plus 1 equals n choose k, a to the n minus k, b to the k. What your formula doesn't have is that this formula here, which I'll put in the box, this is for a plus b to the exponent of n. And what it finds is a specific term. And so what I'll do is I'll do an example with, we'll do an example with Pascal's triangle, and then we'll see how this formula works. Okay? And it's easier to see if we have an example. So the example we'll do is example number 2 with Pascal's triangle to start. We want to simplify 4a squared plus 2b cubed. And because the exponent is 3, whoops, there would be 4 terms, so we know we would go to the 4th row of Pascal's triangle. If we want to expand and simplify completely, 4a squared plus 2b cubed, well, my coefficients are going to be 1, 3, 3, 1. And again, I'll underline my first term in green. We would start off with 3 of those, then 2 of those, then 1 of those. And my second term in purple, the 2b cubed, we would start off with 0 of them here, 1 of them here, 2 of them here, and 3 of them there. Plus sign there, plus sign there. And so if I wanted to simplify this completely, what I'm going to do is I'm going to, again, simplify my exponents first. 4 cubed is 64. A squared cubed, exponent laws, you would multiply. A to the 6 plus 4 squared would be 16. A squared squared would be a to the 4. 2b cubed. 4a squared. Here in purple, I'd have 2b cubed squared, so 2 squared is 4. B cubed squared would be b to the 6. And 2b cubed, that'll be 8b to the 9. So first I did all of my exponents, yes? Is the 3, this cubed here is just on the b. If it was going to be on the 2 as well, they'd need brackets. Oh, and I put it on the inside. Thank you for noticing that. Yes. Okay, so let's take out our fancy eraser. This should have been here, and I totally screwed that up. So that means with our fancy little eraser, there would be no 3 here, no 3 here, just 2b. No 3 there, no 3 there. And as a result, this one will just be b squared. Thank you for noticing that. And this one will just be b cubed. Good. Whew. Could have been disastrous. Now that we've cleared that up, now we can multiply everything out completely, and we will get 64 a to the 6. 3 times 16 is 48, times 2 is 96. A to the 4b plus 3 times 4 is 48. A squared b squared plus 8b cubed. So this is using Pascal's triangle and the pattern to expand it. So if we go back to our formula, what we've basically done is this. That's how we did it this time. And the blue numbers, of course, what's underlined in blue, we got from Pascal's triangle. So now we're going to see how this formula works. So we're going to go back to our example. Oh, I almost copied it all down. Okay. It's all right. Term k plus 1 and choose k. What this formula does is it allows you to find a specific term. So let's say I want to find, pick term 2 or term 3. You want to find the 96 one or the 48? Okay, so let's say we want to find this 96a to the 4b. That's term 2. So if I wanted to find term 2 using this formula, what this formula says is, if I'm finding term 2, what's the value of k? K has to be 1, because whatever term you're finding, it's always 1 more. So if I'm finding term 2, then k is 1, n is my exponent, and in this case my exponent was 3. So it will be 3, choose 1. A is my first term, which in our case, and I'm going to use the same colors. You know how we underlined that in green? So that's going to be my 4a squared. To the power n minus k, well, n minus k would be 3 minus 1, which is a 2. And then my purple number, which is 2b, to the exponent of k, which will just be a 1. Now notice, when you do 3 choose 1, that gives you your 3. Then you would have 4a squared, 3 minus 1 squared, and 2b just once. Does that not match up perfectly with what we wrote? No, that's wrong color. There we go. Fascinating. Does it not want? Okay, there we go. It does not want me to underline that there. That matches perfectly with the second term. So all the formula does is the n choose k part gives you your blue number in front. The second part, a to the n minus k, just tells you what exponent would go with that one if you're going to the second term, and what exponent would go with the last term. And so multiplying this out, you find term 2 perfectly. So another way to do the complete expansion, if I wanted to find all 4 of those, I could use the formula 4 times. I could find term 1, plug everything in. I could find term 2, plug in everything in. I could find term 3, plug everything in. I could find term 4, plug everything in. And it will give you exactly the same as the pattern. Okay? Now, where does this come up and when do we use it? Well, we're going to see that in our next example, which we're going to do right now.